Hello viewers, welcome for today's topic. Please remember that this YouTube channel is created to equip you with IT trends like hacking awareness, data analysis and mathematics. And under mathematics, we are going to focus a little bit more on calculus. I have seen some of higher learning students have been struggling when it comes to calculus. They are saying calculus is a little bit more tricky. Then with this YouTube channel, we are just trying to simplify and show you some of the tricks that you can use to understand this calculus and see that calculus is no more a problem. You can benefit a lot from this YouTube channel. So I think you have to like, share and subscribe and hit that bell icon so that you cannot miss any further videos coming. Alright, so today we are going to just start by understanding what is so-called number system. I think it's a good beginning for you to understand the number system. So number system, we are saying it represents a quantity through a set of numbers. What are we saying here? So let us make an example. Let us say you have a pile of books on your table. So those piles of books on your table, you are going to represent them by giving numbers. Represents a quantity through a set of numbers. So those books, maybe you have a book on top, then we are going to say it's number 1. Below it we have number 2, number 3, like that, meaning maybe you have about 10 books. So those 10 books, you are giving them a quantity, you are giving that quantity of books a set of numbers, meaning you are giving it number 1, number 2, number 3, number 4, number 5 and number 10. So I think you understand the concept behind here. So we have types of this number system. We have types of number system. We have decimal number, which is base 10. Then we have binary number, which is base 2. Then we have octal. Which is base 8. Then we have hexadecimal. We have hexadecimal, which is base 16. All right. On this decimal, we have 10 numbers. We have number from 0 up to 9. We have 10 numbers here. If you can count them, we have about 10 numbers here. Let me change the color. We have 10 numbers. Here we only have 2 numbers, which is zeros and ones. This is the language that computer only understands. Computer only understands binary numbers, meaning it only understands the zeros and ones only. It does not understand whatever you have been typing on your keyboard. So whatever you are typing, it is converting that raw data into zeros and ones so that it can understand it. After understanding, it is going to convert it back to you so that you also can understand, meaning you and computer do not understand the same language. Computer understands the zeros and ones, and you understand the high level language. So I think this concept will be very simple for those who are doing IT. They normally understand what is high level language and low level language. So going back to our topic, we have octal. We have about 8 numbers. These are the numbers that we have in octal. in base 16 we also have 16 numbers from 0 . Then from here we have A. I'm going to explain why do we have A, B, C, D, E, and F. Meaning now A is 10, B is 11, C is 12, D is 13, and E is 14, and F is 15, meaning we have 16 numbers now. Let me do it like this. Meaning in hexadecimal we don't write 10, but instead of 10 we write A, instead of 11 we write 8, instead of 12 instead of 11 we write B, instead of C, instead of 12 we write C, instead of 13 we write D. That continues. Maybe let us say you have a number like this on hexadecimal. Maybe you have 1D. Maybe you have 1D. 1D is what? You have 1 and 30. I think you get the concept now. So now we are going to see how can we convert a number from a decimal to a binary. So today we are just going to talk about these two so that you can understand how does computer convert a high level language into a low level language, whereby it converts whatever you are typing to its language that it can understand, and how does it convert it back from that language to the language that we can also understand. I think you get the concept now. Let me rub this off. Right. Then we are going to convert a number from decimal to binary. Let us say we have 8. We have 8. We want to convert this 8 from decimal to binary. What are we going to do? We have what we call the bits. Let me just start by introducing this trick that we can use. We have 2 to the power 1, and we have 2 to the power 0, and we have 2 to the power 1, and we have 2 to the power 2, we have 2 to the power 3, and we have 2 to the power 4, like this. Alright, so what will be our answer here? Something raised to the power 0, it's 1. We have 1. Let me change the color. We have 1 here. Something raised to the power 1 is itself, meaning we have 2 here. 2 to the power 2 is what? Is 4. Then we have 2 to the power 3, which is 8. And we have 2 to the power 4, which is 16. And we have this one, which is 32. So I'm very sure that you remember you have flashes like, or the memory size of your flash. Some of the flash starts with 1 gig, 2 gig, 4 gig, 8 gig, 16 gig, 32 gig, like that. So these are being called the bits. So we are going to use these bits to help us to convert this 8, which is in decimal. Let me show by writing D here. This one it is in decimal. then we want to convert it to binary. Alright, so we are going to use these bits to convert this 8 from decimal to binary. We are going to do like this. We are going to take our bits that we think when adding them together we can form 8, meaning we can take 1, we can take 2, which is 2 and 1. So when adding them together they cannot form this 8 that we see over here, meaning we have to take another bit. We have to take another bit. Adding this bit together, they cannot form 8 as well, because they are going to form 7, meaning we have to collect another bit. We are going to take this bit, which is 8. So you remember that the answer should be zeros and ones only, not any number apart from this binary type of numbers. Meaning now all these numbers we are not going to use them because they are not going to add to form 8, these ones. Meaning we are going to write 0 here. And remember that when we say something is 0, we are saying it is off state. Off state means what? We are not going to use that number, meaning we replace it with 0. Then we are saying this one, it is off state, and also this 2, it is off state, and also this 4, it is off state, and this one, it is on state because it is forming 8 now, meaning we have 1 here. So this is our answer. This is our answer in binary. Then we are saying 88 in binary is 1000, meaning it's 1000. So let us take our calculator so that we can confirm that we are not doing it wrongly. We have 8 into decimal. Then we want to convert it into binary. You see, this is our final answer. I think now it's clear, you get the concept. So let us take another number and see. Let us take, or let us say now we want to convert 15. Let us say we want to convert 15 from decimal to binary. We have 15 here. We have 15. We want to convert it into binary. All right. Then we have to take our bits now. I wanted to change color here. All right. We are going to take our bits. We are going to take 1, 2, 4, 8. So let me just write it well. We have 8. We have collected our bits now. So let us see, can these bits form 15? We have 8. 8 plus 4 is going to be 12. 12 plus 2 is going to be 14, plus 1 is going to be 15, meaning all of these bits we are going to use them. So remember that when these bits we are going to use them all, we are going to say they are all on state, meaning we are going to use this one, it should be 1, and also this one we are going to use it. We are also going to use this one, we are also going to use this one, meaning our 15 from decimal to binary is 1, 1, 1, 1. So we can just take our calculator to confirm that. We have we have 15 into decimal, then we want to convert it into binary. So you see we have 4 ones here, which is our final answer here. I think you get the concept here. So there are so many ways of doing this, guys, but I found this trick which was a little bit simple and very quick, so that we can understand this. Let us now convert this 8 from binary to decimal. We want to convert this number that you see over here, which is in binary, we want to convert it back from binary to decimal. So what are we going to do here? We are just going to use these bits again, meaning we are going to see how many digits do we have here. We have about 4 digits, meaning we are going to take 4 bits that will be corresponding to our digits. Then we have about 4 bits. Then we are going to check all those who are on state, meaning this one are going to be off state. You see we have 0 here, meaning this one is going to be off state. We are not going to use this, we are going to cancel it out. And also this one we are going to cancel it out, because we are going to say 0 multiplied by 2, that is going to be 0. Then we have to cancel this out, meaning we are just going to focus on this one which is on state, meaning our final answer now is 8. So you see this is very simple, guys. Let us also convert this 15 from binary to decimal. We are having this binary number here that you see. We have this number in binary, then we want to convert it back to decimal, meaning we are going to check how many digits do we have here. We have 4 digits, meaning we are going to take our 4 bits, 2 and 4 and 8. All right, then we see that all of these, they are on state. When they are all on state, we just add all these bits that you see over here, and our final answer is going to be in decimal, meaning we have to just say 8 plus 4 plus 2 plus 1, which is going to be 15. So I think you get the concept, guys. This is very simple. This is how you can convert a number from decimal to binary, from binary to decimal. So let me give you an example here, or exercise that you can do and submit it on my comment section. I will be very happy to see if you really understand this and test your skill. Let us convert this 9 from decimal to binary, and convert this binary to decimal. Please do it and submit it on my comment section, guys. Thank you very much, guys. Please make sure that you like, you subscribe, you share, and hit that bell icon so that you cannot miss any videos coming. Thank you.